Question. Prove this by induction. I answer this question. So for n equals 1, the left hand side equals dx derivative x multiply e to the power of 2x. And this equals, so use the production rule. This is x derivative multiply e to x plus x multiply e to the power of 2x derivative. Then this equals e to the power of 2x plus x multiply e to the power of 2x multiply 2. So this is the chain rule. So then this equals e to the power of 2x plus 2x multiply e to the power of 2x. This is the left hand side. Then the right hand side equals 1n is 1. Here is 2 to the power of 1 multiply x plus 1 multiply 2 to the power of 1 minus 1 e to the power of 2x. And this equals 2x plus 1. Then e to the power of 2x. And this equals, we remove the brackets. So here is e to the power of 2x plus 2 multiply x multiply e to the power of 2x. So compare them. The left hand side equals right hand side. So the result is true for n equals 1. Now assume it is true for n equals k. Then we have derivative k dx k. Here is x e to the power of 2x. And this equals, we just use k to replace n here. So here is 2 to the power of k multiply x plus k multiply 2 to the power of k minus 1 e to the power of 2x. We assume this one is true. Now for n equals k plus 1, the left hand side equals derivative k plus 1 dx k plus 1 x e to the power of 2x. Then this equals derivative dx, and here is derivative k dx k x multiply e to the power of 2x equal this. And now we use this guy to replace this part. So we get derivative dx to the power of k x plus k multiply 2 to the power of k minus 1 e to the power of 2x. Now we get the derivative of this guy. So we use the production rule. So this equals 2 to the power of kx plus k multiplied 2 to the power of k minus 1 derivative multiply e to the power of 2x plus 2 to the power of k multiply x plus k multiply 2 to the power of k minus 1 multiply e to the power of 2x derivative. Then this equals the derivative of this guy is 2 to the power of k. Then multiply e to the power of 2x plus 2 to the power of k multiply x plus k multiply 2 to the power of k minus 1 multiply e to the power of 2x multiply 2. So here we use the chain rule. Then this equals 2 to the power of k multiply e to the power of 2x plus we multiply 2 inside the bracket. So here is 2 to the power of k plus 1 multiply x plus k multiply 2 to the power of k multiply e to the power of 2x. Then go ahead. We combine these two together. So we get 2 to the power of k plus 1 multiply x plus k multiply 2 to the power of k plus 2 to the power of k multiply e to the power of 2x. That equals, here is 2 to the power of k plus 1 multiply x plus, we combine these two together. So it's k plus 1 multiply 2 to the power of k multiply e to the power of 2x. So this is left hand side. Let's check the right hand side. Right hand side equals, so we just use the k plus 1 to replace n here. So this equals 2 to the power of k plus 1 multiply x plus k plus 1 multiply 2 to the power of k plus 1 minus 1 multiply e to the power of 2x. Then this equals 2 to the power of k plus 1 multiply x plus k plus 1 multiply 2 to the power of k multiply e to the power of 2x. Now we compare the left hand side and the right hand side. They are equal. So left hand side equals right hand side. So the result is true for n equals k plus 1. Now conclusion. The result is true for n equals 1. And if true for n equals k, it is also true for n equals k plus 1. Therefore, the result is true for all n belongs to positive integers by the principle of mathematical induction.